G'day, welcome back to the channel. I need you to just forgive the way I look. We've been in lockdown for a bit and I've been tracking a bit tough at the moment, so I'm damn the torpedoes, let's just move forwards. I'm going to skip forward in time. This is a prototype of what we're trying to build, which is a PCB board holder. This prototype functions and works, and I'm physically using it, as you can see. I've actually used it to do a bit of soldering work and cut some stuff, and works just fine. I went from that to this, which was a failure. It was a failure because this bar is too high, and it still works, as you can see, but as you can see, we've had some feature creep. We've now got a handy helper arm which isn't really doing what it needs to do, and the bright wear that's in that's going to get recovered, and the hardware will get recovered, and we're going to go to this, which is the final candidate, and this doesn't really work for me either. The holes are just a tad tight. PCB holders in there. The idea is the handy helper arms in there. It works. It's got modifications in that it's got accessory holes and it's got some mounting holes in it, and this will be the final design. I'm not going to muck with this anymore. You're more than welcome to muck, but this is our final design. In getting to this, we went from this to this to this, and as you can see, I haven't bothered assembling it. I've got to take the bright wear out, the hardware out of this one, and this was a failure. It's got to get recycled, but I'll take the hardware out of that, put it in the new one, and that'll be it. I'm not going to muck with it anymore. Now, let me say here that everything I do and say on these videos, I do so out of the love of YouTube, to try to give back to YouTube for the help and assistance that I've got. And as such, if you're following along, you're doing so at your own risk. So whatever I do and say, take it with a grain of salt, because if you can't accept that you're operating at your own risk, then click this off and away you go. I just trying to give back to YouTube. I'm not looking for fame. I'm not looking for people to be rocking up at my doorstep, ringing me, supporting me, whatever. That's not my reason for doing this. My reason for doing it is to give back to YouTube, and that's it. And I might end this series of videos at any time. I've got health issues and I've got stress on me for my professional life, and I'm just trying to battle through as best I can in the current crisis, and it is a crisis, and I'm in crisis mode. But this is sort of something I love doing. I love fiddling with electronics, and I love fiddling with bits and bobs, and sharing my knowledge when I can. Now, to do this project, you're going to need one of these things. See that thing there? That's a 3D printer. Now, if you haven't got one of those or got access to one of those, then it's pretty much pointless going any further, because you're not going to be able to do the project. However, I do have the files I've created in making this project on GitHub in the repository there, and I will share the repository link in the description below, so that if you want to do this as a project for the kids, as a 3D printing project, which is useful to them, they can. You need a bit of hardware. You're going to need a bolt that's that long. It's a 6mm 6 mil, right? So that is from there to there is 10 mil. So it needs to be at least 10 centimeters. From there to there is 10 centimeters. It needs to be at least 13 centimeters long, this bolt. It doesn't need to have thread for the last 3 centimeters. So it's got to have at least 10 centimeters of thread, and they're M6, so they're metric 6 mil, and they're a standard gauge, right? So I haven't gone to any expense there, and that's a standard it's a 12 mil nut in the center of this, so that when you look at see there's a hole there to take the nut, so that it winds forwards and backwards with that. So that's just a nut and a bolt. That's all it is. Nothing special. I've cut the head off this one and used my own system, but there is an option with this that it's made to fit over the hexagonal head of a normal bolt. Right. This has the option of the handy helper accessory holes, but you can also use that for extendable jaws. So you can make specialized jaws and plug them into those holes, and then it can hold odd shaped PCBs, you know, for example, round ones and hexagonal, stupid shape, odd shaped. I think the iPhone has now got, I know that the Nintendo Switches have a stupid shaped board. So whatever shaped board, you know, you can make a jaw and push it into the holes and hold the board securely while you work with it. So that's up to you. You can do whatever you like with those accessory holes. You can put just round pegs in them, and you know, that might be there, and the jaws come in at whatever point that the pegs bite, you know, and it just holds that board where you need it. Good job. Company's proud. I think that you can come up with all sorts of accessories that you could add, and that's all feature creep, and that's not the aim of this. And so in designing this, I did this as an ad hoc object-oriented design. So it's not full-blown how to do stuff. It's not that. This was just me having a bit of fun in the time, because we were in lockdown and I was thinking about crap. And so, as always, you've got to start with something on paper. And I started with this. And that was my thinking. And then I built this, which, in fact, is this, right? So you can see it's got the screw busy down the middle. It's got bits of coat hanger wire as guides, and that was my thinking. I could use an old coat hanger, and I had these. They're galvanised. They were hook shaped. They had a hook in them with a thread, and you put them into a bit of wire, and you know they're there really as for hanging a bit of wire between, and you tighten them up. You know, and the wire gets tension on it as you tighten it. That's what they were. They were 2 hooks. So I had 2 of these things, and I chopped the ends off them with a grinder. So I'm going to assume that you're going to have the correct hardware. It's just going to be a bolt, you know, more than 13 millimeters long, and it's an M6. I've made it to 6 mil. And you can use gal to save a bit of money. This doesn't need to be stainless, but if you've got stainless, well, you've got stainless, you know. It's more expensive, but it is what it is. You got what you got. You can get some threaded rod if you want to, and just grind one end of it down. If that's all you've got, then just get that. And you can get that at the hardware as well. I went to the nut and bolt place. I always go to specialist shops for whatever I can and support them, because they rely on you doing it. And even though they're a bit more expensive, sometimes they're not. Sometimes they've got exactly what you need at the right price. And, you know, sometimes they don't have exactly what you need, and they'll come up with something. I've always gotten myself you know, if I need tools, I don't go to the hardware for my tools. I don't go to the supermarket. I go to a tool place, and I support them. I give them my business. And if I need my tools fixed, I go to the tool place, and if I can't fix it myself, I take it there. Sometimes I need, you know, bibs and bobs of cheap tools, and they laugh at me, but they fix it, you know, and they charge me for it. And they said, for what, you know, you could have gone and bought a new one of these from the supermarket for what you paid for that. And I just said, but I want to give you the business, you know, so I do. And my tools tend to last. I look after them. So if you've got tools, look after them. Now let's have a quick word about tools while I'm here. What have I got that you kind of need? Well, I'm just going to show you what I operate with. I think you can see most of it there. So let's start with the oscilloscope. That's the oscilloscope over there, right? That was actually free. To buy that, you'd be looking at $300-400. It's a Ricoh. It's portable, so it operates on batteries, but it also has its own plug. Now, I don't think I've ever put batteries in that. I might if I don't know. I might have to check that out. But I got that out of the trash. It was free. The university threw it in the trash. It had a cracked case where someone had sat on it. And the screen was fine, but the outer chassis of that, and there were buttons missing. It had really seen better days. But at the same time, they threw another 2 similar units to that, not exactly the same, but similar units to it in the trash. And the fuse was blown in it. There was some parts on the board. It had water damage on the board, and there were some blown chips, and odds and ends and bibs and bobs were wrong with it. And I had to repair the board. I had to fix the casing. I had to super glue bits here and plastic weld bits there. And if you can tell from the front face of that I've super glued that together, you're a better man than I am, because I can't tell that it's super glued up. And it is. It's super glued up. So I got that for free because I was prepared to do a dumpster dive and fix it, right? So, but if you buy that, you're up for around $200-300. If you're spending anything less than that, probably the quality of what you're getting and the accuracy of it might be in question, but buy what you can afford and look after it. Right, that's that there. Over here is a power supply. I paid $60 for that on eBay. I probably paid too much for it. It's a WEP PS305D, and you can look that up on eBay. I think they go for around $60 with postage. I bought that on eBay. I've no idea what that says. It's a rework, solder rework, reflow. So over there I've got a hot air, and over there I've got the soldering iron. As you can see, I've taken the brackets off the unit itself and put them up on the desk. So they actually sit in there where I need them and where I can get to them easily. So my rework, and that's fallen forward on its thing. I don't know why, but there's the hot air guns there. Now that needs a bit of attention because I've got to put a heatsink on the back of that, and I don't sit it in there until it's completely off. It doesn't turn off just because you turn off the unit. It stays going for a bit, and you've got to have a holder that you can put it into where it's not going to burn the paint on the back wall. So I've got to put a heatsink. I'm going to screw a heatsink into the back of that. I've got one floating around somewhere, an old one. I'm just going to screw it in there, and that'll protect the paint on the wall. Excuse me. Right, so I'm not sure where I was. I just got a phone call. There's some things going on that I need to attend to, so I might have to cut this a bit short. I want to show you that with ad hoc design, I mean, that is a structured start. And most people start building something and fiddle with it, and then they come up with something there and they think, oh, that's terrible, and they turf it. And then they come up with something like this. And in the handy arm, I ended up 3D printing a bunch of stuff that I didn't end up using. I don't know where it's gone. I've got stuff everywhere here. Sorry, here it is. So then I printed these things out, and as you can see, they're just, if you want to, you can add them to your arm, so you can get your arm way up here somewhere. Right, so now we've got an arm that looks like that. It still works. And now you can really get jiggy with where you want to put things on the board. You've got complete freedom of motion there. It's up to you. You can keep building components for it, and you can build, things to hold the, specialised whatevers and bizzos and whizzos and crizzos and stizzos and till the cows comes home. So let's get into it. Again, if you can't follow along at your own risk, click this off. I don't want people rocking up at my front door with frickin' lawsuits and crap like that. That's not why I'm doing this. I'm not doing it for fame. I'm doing it to try to help you out a bit. So this is my PCB holder, and we're going to get into the actual design process right now, and we'll call that part one. Now, before I just do that, let me just say I've got over 30 hours of footage, and I did not tape everything I did, right? So ad hoc design, sometimes you've got a pretty clear idea of what you want, and you don't want to introduce feature creep, and you just want to get it done. A necessity dictates that you do it, and that's where ad hoc design will kind of work for you. But here I had time, because we're in lockdown, I've had time to sit down and think about the design, change this and change. So before physically planning it all out on paper, I've just dived into this ad hoc design method. And I've fallen into the trap of the feature creep, and I've fallen into the trap of not developing the plan on paper before you do this. I mean, I only ever wrote one thing on paper. There it is. I showed it to you. And that's not the way to do this. Design is about going through different ideas on paper and cutting them out and trying them and thinking, no, that's not going to work. And if all you've done is cut out a bit of paper, then you haven't invested any time and materials into it. All you've done is a bit of time, a bit of paper. I went mad with the 3D printing. I waited 10 hours for that thing to print out to decide that it didn't work. 10 hours of printing, and it didn't work, right? And what I found was that I had the printer on the wrong setting. So this was actually printed out. I only ever print out in the rough setting, and for some reason this printed out on the really fine setting. I don't know if you can see it, but in behind here, the supporting material in the back there, rather than it being like 8 millimeters apart, it's only 4 millimeters apart. So all the cross-hatching support framework behind that is really, really, like, you could almost run over that with a bus. It doesn't need to be that. It only needs to be, draft quality. It doesn't need to be super fine quality. But anyway, that took 10 hours to print out for me to decide that I don't want it. And then the final version, this one here, which is you can kind of see that it's, can't get this out. Right, you can kind of see the cross-hatchings are 8 millimeters apart. And it works just fine. I'm much happier with this as a final design than that candidate over there, my production candidate. This is more my production candidate. It's got mounting holes in it that I never thought of in my prototype, and that's the one thing I'll probably end up drilling them into the prototype, because I'm going to mount this to an arm that I can bring into the job and push out of my road. So this is just going to be something that I'll be able to put on the end of an old lamp or something that I've got knocking around in the scrap. I just want the arm bit of it, where I see how that's got that light there's got a little stand and an arm on it, and you could get rid of the light bit and put this on the end of it, and then that can come into your job, and when you finish with it, you can push it up out of your road and it goes away. And that's the sort of thing I want. and I'll have that. Maybe I'll have that with the magnifying arm. I'll build a bracket off to the side of the magnifier and have so I can swing that down under the magnifying glass and do my work, under the magnifier. That's a good idea. And so I can have a bracket for that where I can just, I can swing it up out of my road, or I can swing it down underneath the magnifying glass, and it can sit there until I need it. So I've got a magnifying glass that screws into your desk somewhere, those big magnifier jobbies that you got. So if you don't want the magnifier, you can get the magnifier up out of the road and just use the holder and bring it in. That'll work. Everything works. Everything's got an idea. So let's get on with how to design this, how to do the first stage, which is the design. Let's get into that. Let's start designing this thing. I'm going to swap cameras. I'm going to swap over to the PC, and I don't know what sizes these things are, and I don't know if I want to copy someone else's design. I think you can see I'm sort of doing this out of my head, but generally PCBs are, I don't know, they're no bigger than sort of 10 mil by about 10 centimeters by about 5 centimeters. Most of them for the PCB holders that we're talking about. Yeah, that's not too bad. You're trying to grab hold of something about this big. So my thought is that if you made it 12 centimeters, 120 mil, right? So if we make it 120 mil long, and each of the end stops is 1 centimeter or 10 mil, and then our slide, and we're going to call it slide for want of a better thing to call it, is also 10 mil. So that's just going to be a square block with a couple of holes in it. So the square block with a couple of holes in it's easy. It really is. But the base, how high do you want to make it? I mean, 3 centimeters is probably too much. 30 mil. Maybe not. Right, I think I've got something I'm going to work to. I'm going to swap cameras. Okay, so I've got a problem. Right, there we are. Okay, so hi, back again. So I've quickly thrown this together on OpenSCAD. Let me give them a bit of a shout. This is OpenSCAD. As you can see, they also operate under the GNU and they're open source. Please do this. These are a worthy organisation, and please go to them and donate to them if you use OpenSCAD, and even if you don't use OpenSCAD, go donate to them because it's bloody good software. Right, so I'm using OpenSCAD as the CAD system for our PCB holder, and what I'm starting out with is a square block of plastic. Here you go. I decided that I want the width to be 60% of the length, so that's how I've designed this. You can change these to whatever you want them to be. I'm going to start with that. Now I need another dimension in here, and that is that I need the support width. So I'm just going to call it SW equals 10, and I'm starting at 1 centimeter. So for those of you that need that. Right, so once again we're doing modular design. We've got our holder, which consists of a chassis, and I'm just going to create the void. So I'm just going to go here again. And this will be x minus 2 of these. Y plus 2 mil. And Z's fine. Right? And to get our chassis, what we need to do is we need to difference, we need to cut this out. So we want the chassis, and then we want the void cut out. So that's how we're building our cube, our base. And right now, if we do this, we're going to get it cut out in the wrong place. Let's just show you what's going to happen. Okay, so it's in the wrong place, nowhere near where we want it. The length is fine. What we need to do is we need to translate this, move it. So we're going to do a translate. And we're going to move our cutout in the X direction, that way. The camera is facing in the wrong direction. In the X direction, which is down there, down here in this direction, we want to move it the width, the support width. So we want to go SW. In the X direction, positive, which will put us correct. Now let's just go 0. And in the Z direction, we want to come up the support width. And I know this is going to be a problem because we're not going to come through the inner wall. Let's just do this to show you what happens. You see all of this here, right? All of this stuff here. It's because we've not penetrated the wall. And so to make sure we get penetration, we've added 2 mil. So if we go -1 here, we're going to penetrate 1 mil either side. So let's close that off, and we should get our thing where we want it. And there it is. Right, so there's our bed. Just like that, we've got our chassis and our void. That's pretty cool, isn't it? Everyone like that? I like that. Now we need another couple of things. In one end of this thing, we need a hole, and in the other end of it, we need just a little thing for the screw to sit into, so just a rebate. So we need a hole through one end and a rebate through the other, and we need it. Now we didn't say how big we want our hole to be, so SHD, the screw hole diameter, is going to be, I don't know, we'll make it an M6, 6 mil. I don't know what that needs to be yet. We can come back and change it. And this will be our screw hole diameter. And then we're going to do a GHD. And that's at the moment a piece of coat hanger wire which is about 3 mil. And that's our guide hole diameter. And so let's add them to our void. Right? So we want a cylinder. We want one cylinder that we need, well actually we need 2 cylinders that penetrate and 1 cylinder that just creates a rebate in one end. And that's pretty simple to do. So let's go again into our void. Let's create a guide hole. So let's go, we want a cylinder. We're going to translate this thing. And we're going to come in the X direction of -1. So we want it to go through the end of the guide here. So in our X direction, we're going to travel -1. In our Y direction, in our first guide hole, we want it to be in. Let's go with the SW for the moment, and we might put some kind of a factor times 1.2. You know, just for the hell of it. And in our Z direction, we need to be the SW times 1.5. SW times now we're going to have to fiddle with this one. We don't know really where it's going to land in a final version, but we'll go at 1.5, which will put it slap dab in the middle of the bed. It will be at the bottom of the slide, but at the moment it'll be slap dab in the middle of the bed. And we want a cylinder. And our H equals 2 times SW. Oh, no. No, we've got to rotate this thing. Oh, I'm getting ahead of myself here. So we need to rotate this thing around the y-axis of 90 degrees. So we're going to do rotate 0, 90 degrees in y, 0. And that should put us in the correct orientation. And our height is going to be the length, x, plus 2. Because we're going 1 mil penetration either side, right? Our D equals, what did we say? D is guide hole, GHD, comma. Our center equals false. We need our facets, $FN. 60 will be fine. 60 facets around this, so it cuts us a nice round hole. And we want our center to be false. Center equals false. All right, let's see what that gives us. Poof. Whoa, what did we do wrong there? Rotate. Doesn't like something. Oh, here's our problem here. We've got too many brackets. Right, let's have a look. SW is wrong. That needs to be a capital S. So let's see. Come on, have you put a hole through it? Yeah, look at that. Put a hole through it. There it is. There's our hole through right through the lot. It's dead smack in the middle of the other one. Now, I'm just going to bring this and call it GH guide hole Y and bring it up here. GHY equals Control V. And that's our guide hole indent from the edge. And we want a GHZ. Which we've said it's 1.5. And that's our guide hole. Now this might change, right? This might change. It's not only going to be, it will be the guide hole height. It'll also be our screw hole height. So let's name that more appropriately. So it's going to be HHZ. And let's put that down here. And you'll see why I'm doing this in a minute. Right, so hole heights from bottom. Now we've got to mirror this on the other side. Now we can use mirror, but we're not going to. We're just going to do the same again. We've already got some code, and we're just going to recycle the same code and just move it over where we want it. And this will be in the Y direction, the Y minus it's going to be Y minus that. So it indents inwards. Let's just run that. Ooh, what did I do? What did I do? Variable Y. Why? We have. What do we do there? How did we get that? I don't know. I think, folks, I'm losing it. Okay. OpenSCAD. That sounds good. Let's just put it here. It's. Let's do this first. Okay, let's save this. So I'm making mistakes, doing some stupid things. But there you go. There's our bed. There's our two screw hole, our guide holes. We're not going too bad. We're doing all right. We're doing all right. Now, what we've got to do is we've got to put a screw hole through the center, but it just needs to be rebaited on one end and through at the other. So we're going to, our rebate, it just needs to be so that the screw can turn inside it. So it needs to be slightly, the rebate end of it needs to be slightly thicker than than the screw's going to be. At 6 mil, it's going to be like if it's an M6, it's going to be right there. So we want to just give it a bit more. We want the things to be able to turn freely. inside. Now we're mucking up our neatness over here, and we're just going to tidy that up a bit. So just give it 0.2 of a mil so that it'll spin freely. That's all. It just needs to be slightly bigger than the screw. And that's going to come in here too, and we want another cylinder for that. Now what I've done here is, okay, so this is the bed rebate. This is the right hole. I don't like typing. Hurts my fingers to type at the moment. This is the left. Right. So we've got our bed rebate or bed cutout. Good. This is the right guide hole, this is the left guide hole, and now we want our screw hole. So this is our adjustment screw hole. Now we're going to go SW/2 in the X direction. So it goes halfway in. In the Y direction we want Y/2. HHZ's right. Our diameter is going to be SHD. Everything else can be exactly the same. We don't need this +2 anymore because we don't need to penetrate on one end. So if we run this, I keep trying to save it. I think perhaps I'd better. So I always put my file name up the top. I always do a little bit of this when I did it, you know, just so people know it was me and when it was done and how current the information is. And I will put this up to GitHub and put a link. We've been recording this for a fair old while. I don't know. $20 minutes we've been recording. Okay. We might be doing some editing, I don't know. But let's run this. And there's our screw hole. You can see at one end we've got a rebate, and at the other we've got a right through the middle. So there's our bed built. It's completely built. That's what we're going to end up with. And now finally, we've got to put our sliding piece that sort of travels backwards and forwards. Right, so we've already got the dimensions for it. Believe it or not, we don't need to give it any more dimensions because we've got everything we need. And we're just going to make it. So we're going to call this the slide. And for the moment, we're going to build it in the middle of of the thing. So you'll get an idea of what I'm on about. But then I'll move it to the end here so that when we 3D print, it'll print the two sections as one job. So for the moment, we're going to build it in the center. So because I want to move it later, I'm actually going to define it, the translate up the top. Right, so I want to be up here. And I'm going to put a translate here. I wouldn't normally put these in this. I'd normally define them as a variable up the top somewhere. But for the moment, you know what? ST. Sorry. ST. Translate ST. I will put it up the top. And we're going to say ST equals the, oops, sorry, my mistake, my bad. Got to put it above that command there. ST equals, it's going to be a matrix. Now in the X direction, we don't want to move it. In the Y direction, we're going to move it X over 2. X minus SW over 2, so which should put it right in the middle. And in the Z direction, we're going to go up SW, which should put us on top of the bed. So it should line up. Right, so this is our slide, it's actually going to be the jaw. That's what it is. Right, so that's our jaw. Beautiful. Now we know what to call it. Okay, and all that's going to be is a cube. We're not translating it at the moment. We're just going to chuck some holes in it. How cool is that? We could use the we could use the void. Yeah. Look, we could show you what it's going to look like very quickly. Let's do that. Let's do it. I'm just going to show you what it's going to look like rather than bugger eyes around for too long. You know, just real quick. This is just quick and, no, that didn't work at all. Let's put it here. Oh, look, I'm trying to be too clever. Save. Oh, all right, whatever. Okay. So X is SW. Y is Y. and Z is Z. We should get our slide there. Right. So now we've got to move it where you guys, it'll make sense to you guys. So we've moved it in the Y direction. We want to move it in the X direction. So that's a bit of a furphy there. Control X out of there and put it at the front so it's moving in the X direction. Just bear with me, folks. You know, he's gone mad. So this is what it's going to look like. Right. I've no idea why that's gone up. SW. Oh, Y minus SW. Sorry, I'll get there. Don't worry about me. That did not change at all. I expected that to drop down to the same height. Yeah, okay. I don't know why. I'll fix that in a minute. I asked for a cube, SW. Okay, so you can see here that the design's going off the rails, and there's probably another hour of footage of me fiddling with the design and mucking about. At some point, I realised where I've gone wrong, and quite frankly, none of this was necessary. Had I sat down with my design and put some dimensions on them, I would have had very clear definitions of variables. I would have been able to pick that off from a drawing and put them onto some kind of an entity plan, from which I would have started to build my classes and properties and the sets, lets and gets and blah, blah, blah. And that's proper object-oriented design. Now, we're not doing that, of course. We're ad hocing this, and we're in a mess. You can see how confused I am, and it's all going off the rails. And it goes off the rails. And to the tune of, I've probably got another 3.5 hours of footage to get to the point where I'm actually using the 3D printer. So I'm going to quite a bit of stuff, and you know, just assume that yes, we fiddled and farted and carried on, and we finally got to something that means something, and that was this prototype where we started to print this out. And at that point, we're going to end the video. So I'm just going to chop that out. I'm going to show you to the point where I'm 3D printing the prototype, and we're going to end this video. It's not the way to do this. All right? Right. So let's do this. Bang. We're going to take out the chassis. Let's go, just for the moment, for the hell of it, we're going to go 0. 0 and 0. Save that and run it. So there's our jaw at the origin. Literally, what we need to do is we need to calculate we've already shaved it by SW. So these are the chassis hole heights from the bottom, but our jaw hole heights have to change. So I'm going to change that to chassis hole height Z. And just come down and change that. There. And then I'm going to calculate a jaw hole height from bottom. The 3D print spare parts, I don't know that I even want to bother with the alfoil. I think I just put the alfoil over the bits that are exposed to being splattered by solder and call it done. You know, like just over this bit here. I think that's all we do. I don't think we bother. I'm getting lazy. I really am. You know, I could just as easily cover everything, but I just feel a bit lazy. Okay, let's get on with it. So there we are. We're ready for 3D printing. I'm going to save this. I'm going to export my file. So I'm rendering it for export using the render, and then I'll export the STL. PCB holder, right there. Done. Beautiful. Let's fire up the old 3D printer. Let's get into it. I'm just going to plug in, print one out. Job done. Now where am I? I want to turn this on. Got to do something about this fan. It's working fine. Just noisy. There it goes. All right. So we're turned on. I need to swap over to the PCB printing software. I'm just going to shut this down. I've saved everything. I'm just going to swap over to my control for PCB printing or 3D printing. PCB printing. Yeah, I do have PCB printing software. Yeah, but I want to do 3D printing. Excuse me. I'm going to set this up. Some of you may not have seen this before, but this is the Pt1 host. Once again, worthy company. If you can support them, please do. They have a website like everybody else, to which you can donate, and etc., etc. I haven't done that at this point. It's something I'm going to do when I get a bit of money together. So I'm going to load up my design. Open SCAD. Here's our PCB holder. Open. Let's just have a look at how it lays in. There it is. That looks like it's going to print out just fine. Nicely on the bed. Nice and center. You can see it's got no problems. It's happy to have brought it in where it's brought it in. Just move me out of the road so you guys can see. So I'm going to go into slicer. Now I'm going to change this quality. I've got a solid profile set up, you know. So let's slice that. This is going to take some time to print out. It's going to be quite an involved print. I'm just going to have a look at what it thinks. That looks. See, it's not going to render out too badly. I think that's going to be just fine. But it is going to use up a fair bit of 11 hours to print. So thank you for tuning into part 1 of this video. Remember to subscribe to my channel, like the video, share it with your friends if you so desire. The link for the Git repository will be down below there. Remember to donate to the openscad.org and the Repetia mob for the Repetia host. And that's the end of part 1, and we'll see you for part 2. Make good decisions, do good things. Catch it, part 2.